Let's talk to the relative addressing mode. In relative addressing mode, the effective address is based on the program counter. So what will happen? We know that there is one register program counter. So for example, this is the RAM. Okay, so for example, your first program set of instruction is here. Here is a set of instructions, and the value of PC is at here. Now what will happen? This set of instructions, again this program will swap out and swap in. So next time when it is swapped in, it will be going into the different location, because this location may be occupied by the other programs. So now it is going to the another block of memory, that is another segment. Now PC will be here. So what it is saying, the address will be always value of PC register plus address given in the instructions. So if instructions is given like 05, so it will add to the 05. So initially they are going to access this one before swap in, swap out. Once it is swap out and swap in, now it is going to refer this one. So if we know the program counter value, then we can easily identify to this address. Otherwise it is very difficult, because again we are going to add 5. Then what should be the base? What should be the 5 from? Then we need a reference from which we are going to 5 ahead. So we are using program counter as a reference, and from there we are moving to 5 steps ahead to find out the effective address. So effective address will be here, program counter plus 05, and then we will find the data here, and then we will process. So in index addressing mode we are using SI or DI register, but in the relative addressing mode we are using PC program counter register. So there is not much more differences. Only the differences is the program counter, and the index one we are using the SI or DI register, that is index register. Let's move to the next one. Let's talk to the based index addressing. In the based index addressing, effective address will be the base register plus index register. So there is a base register, that is a special register in the CPU in the computer, that is used for the base index addressing. So like BX and BP is there. Similarly, there is an index register SI and DI. So here effective address will be the base register plus index register. This is useful when we are moving, swap in, swap out the same piece of instructions or same program from one locations to the other locations. So if it is swapped out, now when it is coming to swap in, so it is coming to the another block of the RAM. To know more about swap in, swap out, segmentations, paging, all these things, what is the algorithm they are using, least recently used, most frequently used, what is the algorithm to swap out, swap in, we will discuss in the operating system. Okay, so once it is swapped out, because you know that our RAM is our secondary memory, our hard disk is very big. Now we cannot keep all the programs into the memory, into the RAM at a time. So what is happening, some of the programs that is currently we are running, we will keep into the RAM, and another things we will be sending back to the main memory. In main memory also there is one concept of virtual memory. So it will not go to the directly memory. First it will be, that is the Virtual memory is part of the secondary memory, like our hard disk. So it will go to the virtual memory. So it swap out and swap in will be very easy from the virtual memory to RAM. So once the program, if the RAM is full and now we loaded the new program, they have to remove the one of the segment, one of the page from this RAM to the virtual memory. Which segments has to remove? For that there is a multiple algorithm. For example, least recently used. So like that many algorithm is there. So using that algorithm, CPU will decide, operating system will decide which page has to remove from RAM to virtual memory. Once it is removed, then the page is available, the memory is available in this one, so they will load the new program into the RAM. There is a multiple problems, multiple scenario is there. For example, uh, for each instructions they have to go from virtual memory to here, so it will decrease the performance of your program. So there will be a special like we have to follow some algorithm to optimize this. So this is all part of the operating system, we will discuss it later. Now we understand the base index register, based index addressing. We are using the effective address is the address, the value of the index register plus the base register, that is the effective address. Now this address they will give some number, for example 1024, then it will go to the memory at 1024 and then they will find out the data. Okay. Okay, let's take an example how this program counter relative address is working. So take an example of this. This is a block of memory, this is a RAM. Okay, now what we are doing, one thing important here, you can see it is here, it is used to intra segment transfer. It means that within the segments. So for example, your PC is here right now, program counter is here, that will be the 100, just example. Now here we are getting one instructions to BR, like branch to 50. So what will happen, it has to add 50 into the program counter. So we are going here and this is the 50th positions, so this is the 150th position. So here the it will come here and then it will find the next instructions. So this is like PC relative addressing mode. Why it is inter segment? Because right now PC value is 100. To find out effective address of next instructions, we are going to add 100 plus 50. If it's, why we are not using into the inter segment, because for example if this is a RAM. Now initially here 100 is there and 200 is there, so your program is between the 100 and 200 and your program counter will be some value between 100 to 200. But when it is swapped out, and it is swapped in here, this is the 500 to 700. Program counter is your between 100 to 200, that will be in this case it is 100 only. So we are going to add 50 into that and we are finding 150 here. But the completely blocked is moved to the new segment. Here address will be differ from 500 to 700. Now if you are trying to add the 50, so actually this actual data will be at 550, but your program counter is 100, so program counter will give you the result 150. That is the wrong. So that's why it will not work into the inter segment. So once it is moving to swapped out and swapped in, this will not work. This will work inter segment only, this PC relative addressing mode. And the effective address is the program counter address plus the address fields, whatever the address is given here. This 50 is, we can say, as a This 50 we can say as a offset or displacement, because we are going to move ahead 50 from taking PC as a reference point. So whatever the value in the program counter, we are using that one, and we are moving 50 address next to the program counter. Okay, let's talk about the base register addressing mode. In the base address registering mode, that is again focus on the instructions to find out the next instructions, and the effective address here. Effective address is the base register address plus address field given into the instructions. One important thing here, this is used for inter-segment transfer of control. So program counter or relative addressing mode is based on intra. Now this is working on the inter-segment of control. So for example, this is the one block, it's moved to here, swept out and swept in here. So what will happen? For example, it's 100 to 500. Now here 600 to 1100. Now here base register value will be initially 100. Once it is swapped out, when it is swapped out and again swapped in this case base register will also change from 100 to 600. Now the base register has changed, then the effective address will be easily 600 plus the address given in the instructions. For example, that is, let's take a D only. So initially it was here 100 plus D, now it is 600 plus D. So it's very easy. So code was shift here, we have changed the base register value, then we are easily finding the right address. So this is why it is working on the intersegment. I hope it is clear. Let's see. PC relatives and the base register both addressing mode are suitable for program relocations at runtime. So we already discussed this is important in the program relocations. Program relocations in the sense like the program is shifted from one memory block to the another memory block. Why it is happening? Because of the operating system. Some of the new application is coming. So they have to vacate the RAM, vacate the main memory, and then they will bring the new instructions or new program into the memory, whatever is going to be used. Similarly, when again they are needing the same program, so set of program will be again come to the memory, but this time the address will be changed. It could be changed, it could be the same, so it depends. So it will be changed. If it's a change, then that is called the program relocation. Okay, now the base register addressing mode is best suitable to write position independent code. What it means, where we are not worried about which positions, so because it is moving from one locations to the other locations, so it will make you the program as position independent. So that is very useful for writing a program that is a position independent code. I hope I cover all the addressing mode. If you think that this video is useful for you, so please go and subscribe and share with your friends. Thank you very much. Next video I will come with some of the MCQ for the addressing mode. So be ready with this concepts we are going to use into the next MCQ section. Thank you very much.